All right, hello and welcome again, guys, to the second lesson in this probability series. This one is going to be on multi-stage events, and I'm calling this one multi-stage events part 1 because we're breaking it up into the easier and then the harder questions. Obviously, part 1 will be the easier ones. So for those people that are getting all these notes in their books and are like wanting it all there for when they're looking back and revising over this topic, this would be your heading, multi-stage events part 1, and this will be your notes. So pause the video as required to copy down any notes you need. Now, what are we going to be covering in this lesson? Well, specifically, we're going to be looking at multi-stage events. What makes finding the probability of multi-stage events a little bit trickier than your normal basic probability is going to be the sample space. It's not as immediately obvious. So if you look at a simple case of you roll a die, what's the probability you get a 5? Well, you straight away know what the sample space is, right? And by sample space, I mean, all the possible outcomes. You roll a die, you get the 1, 2, 3, 4, 5, or 6, right? There's only 6 possibilities, they're the numbers. So the probability you get a 5, well, there's 1 5 out of a total of 6. So it's 1 over 6. You got the probability straight away. It requires 0 working out, 0 real thought processes beyond the most obvious. Multi-stage events, though, is trickier because you don't always know exactly what the sample space is going to be. Let's look at the example of, let's say you roll 3 dice, you're adding them together, and what's the probability that you get a score of at least 10, right? Now, again, as far as probability, it's kind of just as easy as your basic probabilities if you have the sample space. And that's what makes multi-stage events trickier. Fortunately for you, that's exactly what we cover in this lesson. I'm going to teach you how to find the sample space. And for those people that have been copying down or reading these notes, there's 2 typical ways we do this. We can use a tree diagram, or we can use the sample space table, right? So again, first thing I really need you to know right now is to find probability, you need the sample space. What is the sample space? It's just the list of all possible outcomes that could occur. So if you roll a die, you could get 1, 2, 3, 4, 5, or 6. If you flip a coin, what's the sample space? You get a heads or a tails, right? And that can get a little bit trickier when you have, specifically for this lesson, 2 different events happening. So let's go on to our first example. Let's imagine the scenario, you've got a coin and it's been flipped twice. So there's no longer just one event happening, there's 2 events. This is why it's a 2-stage event. Now, part A, I'm being super nice. I'm actually asking you to list the sample space. Now, again, this one is pretty basic. A lot of you might actually already know instantly what that sample space is, but for those that haven't seen questions like this before, that's okay. I'm going to show you how to do it right now. So the 2 main ways, the first one is what we call the tree diagram. So the way the tree diagrams work is, hey, Lawson, what is it, man? Not right now, okay?
Okay.
I'll be out in a little bit. All right, thanks. Okay, so the way we do our tree diagrams is we start off with, well, what is the first thing happening? Right, okay, the coin is being flipped. All branches, they start off with a stem, and then they start branching out. Every time we have a new event, there's going to be a couple different options, and that's going to create some new set of branches. So in this particular case, the first set of branching is when we flip that first coin. How many options can you get when you flip a coin? 2. So there's going to be 2 branches. You could have got, the event could have branched off and you could have got a head, or there's also the very real possibility you could have got a tail, right? That's our first stage of the event. And then once that's done, what happens? All the coin gets flipped again. So when you flip the coin again, how many different outcomes are there? There's 2. So branches branch off into more branches. From the end of each branch that we currently have, we're flipping the coin again, And so there's 2 more options. So we're going to need some more branching off. The first set of branches, which is right here, this was our first coin flip. The second lot of branches happened right here. This was our second coin flip. And that's where the situation ends. What you end up with and where we get the sample space is just by reading off the final endpoint for our branches. If you look at the top scenario, this is a scenario where you got a head with the first coin flip and a head with the second coin flip, right? So you got 2 heads. The next branch down, this, right, you follow the arms. What I'm doing is I'm actually following these arms to get to this endpoint here. And what did we get to this endpoint? We got a head on the first coin and then a tail on the second flip. The next one, right, these are the arms that lead to that endpoint. This is us getting a tail on the first coin, a head on the second, and the final one you could get 2 tails. This right here is a list of all possible outcomes. Once you have that sample space, there's going to be no probability question that's particularly challenging. Let's have a look at some probability questions. So down to part B. Find the probability you get 2 tails. Well, you look at the sample space, there's 4 different possible outcomes. And in this case, we can see getting 2 tails only happened once out of a total of 4 possible times, like outcomes. So it's just a 1 in 4 chance. What's the probability you get at least 1 tail? Well, out of the 4 different possibilities, how many of them had at least 1 tail? There, and there, right? So in this case, we have the probability would be 3 out of a total of 4. And the final probability question, what's the probability you get exactly 1 tail, right? You flip the coin twice. What's the probability you get exactly 1 tail? Well, that was here and here. So in this case, we added a total of 2 out of 4, or if you wanted 2.5. By the way, I've expressed these as fractions, but there's nothing stopping you from writing them as decimals or percentages. They would all be marked correct, and they all are the probability, just written in different ways. So see how quickly and easily those probability questions were once you know what the sample space is. It's getting the sample space, which is the only tricky part of this topic. Now, I told you there's 2 different ways. I've shown you one. I will show you right next to it the sample space table. The way these sample space tables work is they're actually a little bit neater and smaller than the tree diagrams, and most students do find them easier. So why would we even bother using the tree diagram? Well, sample space tables only work for 2-stage events. Tree diagrams can be used for 3, 4, 5, as many stages as you want. They can get way too, large and convoluted, but they can be used for multi-stage events. These sample space tables, which I'm going to show you right now, they only can be used for 2-stage events, which fortunately for us is the most common question anyway. All right, so how do they work? Well, what's the first thing that's happening? We're flipping a coin. All right, so what we're going to do is right across the top, all the different possible outcomes you get from flipping a coin. You could get a head or you could get a tail, right? That was the first thing. Along the other column going down is where we're going to put the options for the second thing that's happening. Again, we're flipping the coin again. You can get a head or a tail. What this has created is a 2x2 grid, where if we fill it out, this first box right here, this was the scenario where you got a head and a head. The second box, the one across from it, is a scenario where you got a tail and a head. The next box down, this was a scenario where you got a head and then a tail, and then this was the situation where you got a tail and a tail. Notice how this table here gave us the exact same sample space as the tree diagram. The head, the head, tail, the tail, head, the tail, tail. If you do it in a different order, it doesn't matter. but you've got your 4 different outcomes. They're all listed there, and you could have just as easily have looked at these 4 things, these elements, the sample space, to find and calculate those probabilities. So we actually have 2 options here, the sample space table or the tree diagram. You're going to need to know how to use both. You'll obviously have your preference, the one you prefer to use, but get good at both. And let's look at our second of our 3rd examples. By the way, if you are getting down the notes, pause the video as required, get down your examples, and once you're ready, just unpause. All right, example 2. So in this case, we've got a like a money wheel. It gets spun twice. Let me do a little bit of editing here. To win money, you need to spin the same amount both times, right? So you go up, you spin, oh, this is easy, $10, $50, $100, let's spin it. Okay, that's cool, you got an amount, you haven't won anything yet. You got to spin that wheel a second time, and you have to get that same amount again to actually win the money, right? So in this particular case, we've got some probabilities we're going to find. We want to find, well, what is the probability you win $100? Okay, lots of people would say 1 in 3, and they're wrong, right? It's not that at all. This is a multi-stage event. You got to spin the wheel twice. The only way you win $100 is if you spin $100 on both times, right? It's not 1 in 3. But we're going to find that probability. It's going to be so basic once we have the sample space. We'll also find the probability that you win at least $50. And the final one is the probability you win $10, but it's got that like line above it. That line means the complement or the opposite. So the actual final question is asking us to find the probability that we don't win $10. Okay, so again, it's going to be very simple once we have sample space. So with that being said, let's get the sample space. We're obviously going to use both methods. This time I'll start with the sample space table. So let's 2 things that are happening. So I'll get my 2 sides to the table set up. All right, we're spinning the wheel. And it doesn't matter if you put the first options across the top or across the bottom, right? It'll slightly rearrange, the order of the terms inside the table, but ultimately you're going to get the exact same sample space. All right, so you spin the wheel once. What are your different options? I'll keep it across the top though for the first. You could get $10, you could spin the 50, or you could spin the 100. All right, that's our first one. The second thing we do is we got to spin that wheel a second time, where again you could get the 10, you could get the 50, or you could get 100. This has created a 9x9 grid. The wonky, anyway, it doesn't matter. All right, so we've got ourselves our sample space table drawn up, and let's fill it out. So this first box, this is where you spun the 10 and the 10. This actually has us winning $10. We spun the $10 both times. I know it's not a lot of money, but at least we won. The next box along, you spun the 50, right? You're all excited. I spun a 50, yes. You go to spin it again. Unfortunately, you spun a 10. You've won nothing. And this third scenario is also quite heartbreaking. You spun the $100. You thought, yes, this is great. I might be able to buy, I don't know, like a couple meals at KFC, maybe not a whole lot. But you spun a 10 on the second spin. You've come up with nothing. Again, same as this one here, the 10 and the 50 will get you nothing. Okay, this is good. You spun 50. You spun 50 again. Congratulations. You've won $50. And no good for that one. No good, no good. And down here is the best case scenario for this game. You spun 100 both times. You've won your $100. So there was 9 different possible configurations when spinning this wheel 3 times. By the way, that's not surprising. There's 3 options on the first spin. There's 3 options on the second spin. There's 9 different outcomes. Right, they call that the fundamental theorem of counting. But anyway, so it was 9 different outcomes, which is what we got, and we worked out, how many different ways you could win. Once we have that sample space, again, probabilities are going to be very simple. So in this case, what's the probability you win $100? Well, check it out. There was one way out of a total of 9. So that's the probability. Like 11.1% if you're doing it as a percentage. Whatever units you want to use, that's fine. The next one, what's the probability you win at least $50? Well, in this case, how many different ways could we win $50? There was 2 out of a total of 9. So it's 2 out of a total of 9. That's that probability, right? See how simple they are once you have the sample space. And this final one, which might have seemed like on the surface tricky, but what's the probability you don't win $10? Well, if this is us winning $10, the probability we don't win $10 is every single other one. Or in other words, you have an 8 out of 9 chance of you not winning $10. So hopefully that makes sense. And that's the question done, right? As it stood, all the question asked you to do was find 3 probabilities. You've done that. The question didn't ask you anything about tree diagrams or sample space tables. They just asked you to find the probabilities, and we've done that. Of course, I'll down here just again show you how to get this sample space using the tree diagram if that's your preferred method. Even if it isn't, you're going to have to know how to do it anyway. Let's check it out. Start off your tree diagram with a point. Get to your first set of branches. You spin the wheel. What can happen? You could get a 10, a 50, or you could get 100. We've got 3 sets of branches. All right, you've done the first spin. We're then spinning the wheel a second time. Again, there's going to be 3 different options. So we need 3 sets of branches coming off each previous end. And you can see why I personally am not a fan of the tree diagrams. They very quickly get large. And this was only a wheel with 3 options. Imagine with something with 5, 6, or even more options, the tree diagrams can get massive very quickly. And then at the end of each branch, this is where you get your sample space. The first one was here. You got the 10 and the 10, right? This was us winning $10. The next branch was 10 and 50. There was no win there. No win. No win. This was a win of $50, no win, no win, no win, and a win of $100. Again, you just follow the arms to each endpoint. All right, and so there you have your list of the sample space. There's 9 different options, and there was 3 of them that were winning. So that's again how you could use the tree diagram to get the exact same sample space. All right, on to our very last example for this lesson. So this one here is a little bit trickier. It's what they call a question where there's no replacement. I'll explain I guess I'll explain right now. It's where the same option can't come up twice. So for example, let's say you had some different colored marbles that were in a bag, and you're picking out a couple marbles for a particular game. Once you take a marble out, that marble is no longer in the bag. So when you're picking out your next one, the previous marble's no longer there. So the probabilities will adjust and shift a little bit. It's once you see an example, it'll make sense. And again, although it's maybe a little bit harder, it's not that much harder. So I'll show you with this example here. For those that are copying in these examples, apologies for the length, but it's just the way it is. If it makes you feel better, I had to write it too. All right, so the names Alf, Beth, Kaz, Drew, and Emily are written on pieces of paper and placed in a hat. The first name to be drawn will become the captain of the team, and the second will become the VC, or what will be vice captain. All right, so that's the situation, right? So there's 5 pieces of paper, a name on each one. They're placed in a hat, and we're drawing out 2 names, and that's how we're going to get our captain and vice captain. The questions are as follows. We're trying to find what is the probability Emily is the captain. And then the other, like that's the only provision. We just want to know what's the likelihood or the probability Emily becomes the captain. And the other one, what is the probability that neither Drew and Alf were selected, so neither of them become captain or vice captain. So again, without a sample space, if I just said to you, okay, go, especially with the second one, what's the probability? Can you do it in your head? Right? If I told you flip a coin, roll a die, what's the probability you get an even number? Right? You can do that in your head. It's 3 out of 6. Because you know already in your head, without writing anything down, what the sample space is. With the sample space, probabilities are easy. This one here, the sample space is not so immediately obvious, which is why the probability is still just as easy as the sample space, which is harder. And that's why we use these techniques that we're covering to get that sample space. So let's look at this one here. So let's do, it doesn't, I'm going to do both methods, let's be honest. I'll start off with the table, I guess, because it will be smaller. Okay, so in this particular case, you could get, the first name drawn out could be Alf, Beth, Kaz, Drew, or Emily. The second name could have been Alf, Beth, Kaz, Drew, or Emily. We don't know anything, really yet. And what this ends up creating is a 5x5 grid. And so you might say, oh, okay, well, the probabilities are going to be out of 25, but not quite with this one because there was no replacement, right? Although the question didn't specifically say there's without replacement, lots of questions will actually say no replacement. This one here, it was just so self-evident that a person couldn't be captain and vice captain. Once that first name gets taken out, hey, congratulations, they're the captain, they're not putting that name back in to then potentially become a vice captain, right? That name's already been taken out. There's only 4 names left for the second name to be drawn. But anyway, we end up with this grid of 25, and we'll see what happens, for the, the Alf. Ultimately, we're going to have to just ignore them and cancel them out. So if you look at the very first box, this is a box that actually does not make any sense at all in the situation. Alf could not have been the first and second names drawn out. So for the context of this particular question, this box is not even valid. Like, we ignore it, it does not exist. The next one is good though. This was a scenario where, and again, it doesn't matter if you're going here first and then here, or the other way around, because both options will be in there at some point. But I'll be doing top and then sideways just because that's where I've been doing it so far this lesson. Okay, so this next box is a scenario where Beth got pulled out first, so she's captain, and then Alf is vice captain. The next one along has Kaz as the captain, Alf is the vice captain, Drew could have been made captain, Alf is vice captain, or we could have had Emily as captain and then Alf as vice captain. When we go down to the next row, this is a scenario where, again, I'm doing top first and then the side one. Okay, Alf is captain, Beth is vice captain. The next one is a scenario where Beth got selected first and last, which actually cannot happen. It's a box we need to ignore. Kaz as cap, then Beth, Drew, then Beth. Okay, you guys can probably see what's happening. I'm just sort of going to quickly fill it out so you don't die of boredom. Beth and then Kaz. Kaz and Kaz needs to be blocked out. You guys can already see what the trend is going to be here. And again, this is Emily as captain and Kaz as vice captain. I'm really, focusing on this final column because I've already read the 2 questions, right? So my mind is already automatically like magnetized to like, when is Emily the captain? Anyway, and on to the second last row. Let's go Alf and Drew, Beth and Drew, Kaz and Drew. Drew and Drew cannot happen. Emily and Drew can be a team though. Alf and Emily, Beth and Emily, Kaz and Emily, Drew is cap, then Emily is vice cap, and Emily cannot be both captain and vice captain, so that one doesn't exist. All right, so from here we have our sample space. Apologies for the time taken. Hey, it's going to get worse. We are going to do a tree diagram afterwards. Let's quickly answer these questions so at least we can have the question done. Find the probability Emily is captain. So look at all the different scenarios where Emily was captain. She was the first one chosen. There's, again, we're talking about these ones. Well, not sure how that happens then. We're talking about these ones here. So in this case, we're dealing with the probability. It is 4 out of a total of 20. Or in other words, there's a 1 in 5 chance, a 20% chance, however you choose to write it, 0.2. Okay, so that's the probability Emily is captain. What's the probability neither Drew or Alf were selected? So you're just looking for all the ones where neither Drew or Alf were in it. So that should be easy enough. Here we go. All the ones with no Drew and no Alf. Okay, I may have all of them. I have no idea. Okay, so in this particular case, here we go. Assuming I found them all, we have 1, 2, 3, 4, 5, 6. So there was 6 out of 20, or in other words, 3 out of 10, 30% chance that neither Drew or Alf were captain or vice captain. So this is a case where if you do have a question where there's no replacement and you're doing your sample space tables, you'll end up with these boxes that you just don't include because they just don't make sense for the question. Either it's impossible to do or, well, it's impossible to do, right? So this is what I would consider one of those sort of, a little bit harder than just the most basic, 2-stage event type questions. So hopefully that made sense. As promised, I'll quickly put together a tree diagram of this scenario. So I'm not nervous at all about it. It'll be heaps of fun, I'm sure. So when the first name gets taken out of the hat, how many different options were there? There was 5. 1, 2, 3, 4, 5. I've put nowhere near enough gap here. I really needed to make it larger. But you could have got, for the first name, very genuinely, you could have got Alf, Beth, Kaz, Drew, or Emily. There's 5 different options when you pull that first name out. Once you pull the first name out, how many names were left? There was only 4 in the hat, right? So when you take that second name out, there's only 4 options. So you only do 4 branches for the second option. And you know how I said I didn't do enough room in between? It's because now they're all scrunched up. But if you look at the first one, we'll at least start it off anyway, just so you can see how to do it. If you got Alf as the first one, what were the 4 different possibilities for the vice captain? Well, you could have got Beth, Kaz, Drew, or Emily. Right, and the next one, if Beth, right, I'm now looking at this scenario here, where Beth was the first name that got pulled out. Well, in that case, your vice captains could have been Alf, Kaz, Drew, or Emily. And, so on and so forth. You would go ahead and fill out the rest. And what you'd end up with is, in the total, you'd end up with a list of 20 different options, which will be the exact same options that were in the table. right? So for two-stage events, whether you're using the table or the tree diagram, it does not matter. You will end up with the exact same sample space. If you've got the sample space, see how easy those questions were. They were really basic, right? Probability is never tricky. It's the sample space which is tricky to get. Anyway, hopefully this lesson made sense. Practice. If you have any questions about either the tree diagram or the sample space tables or how to use them to find probabilities, feel free to let me know either through this video or back on Canvas, and I'll help you the best I can. Anyway, hopefully this helped. Best of luck with your probability questions, and I'll see you for the next video. Okay, bye.